In this video, we're going to look at the difference between mathematical combinations and permutations. Now, for combinations, we have the notation NCR, and this means NCR is a number that you can calculate, and it tells you the number of ways of choosing R items out of n. So we have n items and we're choosing R of them without replacement and the key thing that makes it a combination is where order does not matter. Okay. So let's say we're choosing balls of different colors. Then if we get a blue ball then a red ball, that's the same as getting a red ball then a blue ball. The order does not matter. And there's a formula to calculate to work out what this number is. The formula is n factorial divided by r factorial times n minus r factorial. And if you're not sure about what factorials are, to get n factorial, it's just 1 times 2 times 3 times 4 times 5 times whatever up to n. So you multiply all the whole numbers up to n, gives you n factorial. So this is what combinations are. So in contrast, permutations are pretty similar. So NPR, in this case, it's the number of ways of choosing R items out of n, again without replacement. Now the key difference is here where order does matter. So selecting a blue ball, blue, red is different to red, blue. So that's the key difference between permutations and combinations. In permutations, the order does matter. So, and the formula in this is slightly simpler. In this case, it's just n factorial over n minus r factorial. Okay. So the easiest way to think about this is with an example. So let's have a look. E.g., suppose we have 4 items A, B, C, D. And then if we're asked to find what is 4C2, well, that's the number of ways of choosing 2 out of these 4 items where the order does not matter. So then so we can sort of list these items. So we have AB. We don't need to list BA because it's a combination. That's the same as AB. So we only list AB. We don't list BA. We have AC, AD. We can have BC, BD, and CD. So they're the different pairs of items. We're choosing 2 items out of this group of 4, and there are 6 ways to do this. So 4C2 is equal to 6. When you're listing the items, if you're doing it this way, it's useful to have some sort of order. Here I did all the ones that started with A first, then the ones starting with B, and then finally the ones left over. And we can check this with the formula. Remember, 4c2 is equal to n factorial, that's 4 factorial, over r factorial is 2 factorial, and then n minus r factorial is 4 minus 2 factorial. This is 4 factorial over 2 factorial times 2 factorial, and 4 factorial is 4 times 3 times 2 times 1, and 2 factorial is 2 times 1, and 2 factorial again is 2 times 1. This is 4 times 3 times 2 times 1 on top. Is 24 over the bottom is 2 times 1 is 2. So this is 4. This is 6, which agrees with our counting. Which is good. On the other hand, if we're going to do 4p2, this is the way of listing them where order does matter. In this case, we have AB, AC, AD. Now we are going to list BA because that's different to AB because for a permutation because the order does matter. So we also have, so these are the ones that start with A. We also have the ones that start with B. So BA, BC, BD. We have the ones that start with C. So CA, CB, CD. And then we have DA, DB, DC. Notice that we don't have AA or BB or CC or DD. The reason is because we're looking without replacement. So without replacement means we can't draw the same thing twice. So that's why we don't include AA, BB, CC, DD, etc. So having a look at this, there's four lots of 3. So that is, we think 4p2 is 24. And again, just using the formula, we can check that. So 4p2 is 4 factorial over 4 minus 2 factorial. 4 factorial we worked out before is 24, and 4 minus 2 factorial is 12. Obviously, before when I said 24, I was being a little bit silly, and I meant to say 12. And 4 minus 2 factorial is not 12, it's just 2. This is 24 over 2, which is 12. That's a quick example of the difference between combinations and permutations with an example of each.